Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now in the last video, we did some numericals on equations of motion and acceleration. Now in this video, we'll be continuing the numericals on kinematics. So let's move and talk about the first numerical. Now the first numerical says that a driver takes 0.2 seconds to apply the brakes after he sees a need for it. This is called the reaction time of the driver. If he is driving the car at a speed of 54 kilometers per hour and the brake causes a deceleration of 6 meters per second square, find the distance traveled by the car after he sees the need to put on the brakes. Now, actually, the question says that the car is being driven with the speed of 54 kilometers per hour. Now, if you want to convert this into meter per second, the trick here is that simply multiply 54 with 0.277. Now, after multiplying 54 with 0.277, the answer will automatically be converted into meter per second, right? So this is actually the trick. So the question says that you are driving a car, and let me suppose at point A you realize that you need to put on the brakes, right? So according to the question, it will take you 0.20 seconds to actually apply the brakes from point A, right? Now let me suppose in 0.2 seconds or I can say the car has reached to the point B, right? So it is the point B at which the brakes have been finally applied, and let me suppose the car finally stops at the point C. So according to our question, we need to calculate the distance traveled by the car after he sees the need to put on the brakes. So actually we need to calculate the distance. We need to calculate the distance of AC, which will be equal to simply distance AB plus distance BC, right? So let's move and calculate distance AB first. Now, since the car was driving with a speed of 15 meters per second, from our definition of distance, we know that distance is simply, or I can say speed is simply distance by time taken, and from this I'll get distance is nothing but speed into time. Now distance from AB will be simply the speed that will be from A to B, that was simply 15 meters per second, and the time between AB is simply 0.2 seconds, so I'll write it here. So the distance AB will come out to be simply 3 meters, right? So 3 meters, we have got our first solution. Now let's move and calculate the distance BC. Now the question says that at B the brake actually causes a deceleration of 6 meters per second square. So since it is a deceleration, acceleration can be negative here, right? So it will be negative. So what will be the distance traveled during this process? From our third equation of motion, I can write v square minus u square will be equal to twice as. Now since its final velocity will be equal to 0 because the car has finally stopped, its initial velocity was 15 meters per second, so I can write something like this, and since acceleration is negative, I can write it like this, and distance will be as it is. So this is nothing but minus and minus will cancel out, and you will be left with 15 raised power square divided by 12, and that will be your distance. Now this comes out to be simply 18.75 meters, right? So what will be our total distance traveled? Our total distance traveled will be simply 3 meters plus 18.75 meters. So the answer will come out to be simply 21.75 meters. So actually the car travels 21.75 meters before it finally comes to rest. Right? I hope you have understood this. Now let's move and talk about another problem, and that is a stone is dropped from a balloon going up with a uniform velocity of 5 meters per second. If the balloon was 50 meters high when the stone was dropped, find the height when the stone hits the ground. So let me draw the problem for you. Now the problem is that you have a balloon, right? You have a balloon and it is moving up with a uniform velocity of 5 meters per second, right? Now it is from 50 meters from the ground. When a stone is dropped, let me say this is a stone. Now a stone is dropped from the balloon, right? So I need to calculate the height when the stone hits the ground. So let's calculate the time in which the stone will finally hit the ground. Now if I assume that the initial velocity of the stone is 5 meters per second, let me calculate the time, and its final velocity will be actually equal to 0 because at ground it will finally come to rest. So let me calculate the time in which it has finally reached the ground. So the time will be simply calculated from the second equation of motion, and that will be simply S will be equal to ut plus half of at squared, right? Now since the distance is 50 meters, I'll substitute it here, and its initial velocity is 5, time will be as it is, plus half of, now acceleration, it is given that acceleration is to be 10 meters per second, so I'll write it here 10, and t is as it is, right? So what our equation becomes is that you'll have 50 will be equal to 5t plus 5t square, or I can write simply 5t square plus 5t minus 50 will be equal to 0. Now this is a quadratic formula, and it can be solved with a quadratic equation. So I'll directly write the answer for t. Now t will have two answers because the power here is 2. So one value for t will be simply minus 2.7 seconds, and another one will be simply 3.7 seconds, right? So neglecting the negative value of time, I'll consider only the positive value of the time. Now this is the time when the stone has reached the ground. Now in the meantime, the balloon has actually risen up to some distance, right? So let us calculate the distance which the balloon has risen in this time, right? Now it can be simply calculated from the equation of speed, and that is simply speed is nothing but distance over time, or I can rearrange it as distance will be simply equal to speed into time. Now the speed of the balloon is 5 meters per second, so I can write d will be equal to simply 5, and time is simply 3.7 seconds, so I'll substitute it here, and d will be simply nothing but 18.5 meters, right? So I'll get 18.5 meters, right? So the total distance from the ground will be simply 50 meters plus the extra distance the balloon has traveled in 3.7 seconds, and that is simply 18.5 meters, and the total distance comes out to be simply 68.5 meters, right? I hope you have understood this.